In this video, we are going to build a more complex application from scratch. In this case, we're going to implement an application to show a list of food. Each food is assigned to a category, and we can also see a chart of an overview of the food that we have in the table. This will be the main appearance of our application. As you can see, there is a table showing a list of food. For each food item, there is a food name, food category, the weight in grams, and the weight in ounces. We can add as many pieces of food as we may need from the form below, and we can also see a chart summarizing the contents of the table, grouping the food by category. This is what we are going to build from scratch in next steps. First of all, we need to create a new project, a new JavaFX project from IntelliJ, and we are going to call it Healthy Menu. At the beginning, as you may know, there is a sample initial package with all the contents on it and a main application that will launch the JavaFX stage. In order to fix the compilation errors that we may find at the beginning, we need to add the corresponding libraries to the project. We right-click on the project name, go to Open Module Settings, and we go to either libraries or global libraries. We may find the JavaFX libraries already set in global libraries, but even though they are added, we can find compilation problems, as we may notice. So we remove the libraries from here and add them again. We choose the folder where the libraries are located and add every jar file to this section. This way, every compilation error is automatically fixed. We also need to add a module info file in our project in order to determine the internal dependencies of the project. We need to require JavaFX controls package along with JavaFX fxml package, and we need to export or open our sample package. But before this, we are going to rename and arrange properly the packages and classes in this project, since it's going to be a more complex project. So sample package is going to be renamed as Healthy Menu, for instance. And inside this package, we are going to add a sub-package called views, for instance, to store every fxml file along with its corresponding controller. Inside this views package, we add a new sub-package to store the main stage with its controller. And finally, inside this main package, we are going to move the controller and the fxml file. We refactor every possible change in the rest of the code to refer to these files. And also, we are going to rename sample fxml file to main fxml file, for instance. If we try to rename here the file, we call it main. Also, in the main class, this change is automatically added. In this main class, we just change the title of the window or the stage to Healthy Menu. And we can also set a new preferred size for this window, since we need it to be larger. For instance, 10 pixels. For instance, 10 pixels. 650 pixels width and 400 pixels height. That's all. So in our module info file, we need to open healthy menu along with every internal subpackage that we need to access. In this case, healthy menu, views main. As the application grows in next steps, we are going to add more opens lines in this file to export every affected package. So now it's time to start defining the layout of our main window. We open main fxml file and go to Scene Builder tab to define the main layout. As you should know by now, Scene Builder or IntelliJ automatically adds a default main container, which is a grid pane. In this case, we don't need a grid pane. We remove or delete this main container, and we are going to use a vertical split pane instead. We drag and drop this container into the main area, and as you can see, split pane consists of two anchor panes, one for the upper part and one for the lower part. It's okay for us for now. In the upper part, in the top of this split pane, we are going to add a table view. We go to Control section and choose a table view control. We drag and drop it here, and we can right click on it and choose fit to parent. So the table grows to fit the parent's container, the anchor pane. Inside this table view, we need to set 4 columns, one for the food name, another one for the food category. The third one corresponds to weight in grams, and the last column will show the weight in ounces. By default, a table view is added with 2 columns. We can rename them as food name and food category. We can also resize them. And then we need to add 2 more table columns inside this table view. The third one is going to be the weight in grams, and the last one will be the weight in ounces. This last column will be automatically calculated from the previous one. We are going to convert grams in ounces. Now it's time to assign an FX identifier to every control that we have already placed. Starting from the table view, we can call it table food, for instance, and every column can also have its own name. In this case, for instance, can be called food name. Second one will be called food category. The third one is called food weight in grams, and the last one is called food weight in ounces. So now it's time to move to the bottom section and define the form to add food to the table. In this case, we are going to add some labels and buttons and arrange them properly in order to resize the window whenever we want. Let's start by adding the controls. For instance, we are going to add a label for each field, a label for the food name, another one below for the food category, and a third one to refer to the food weight in grams. We can resize the labels in order to have the same width for all of them. And then we need to add two text fields, one text field corresponding to the food name and another one for the food weight in grams. And finally, we need a combo box or a choice box, as you prefer, to select the food category. Finally, in order to add a food item to the table, we need a button to click on. Let's place it here and call it add. We can resize it. And this is the main appearance of our bottom form. But we are going to group these controls in internal containers in order to arrange them properly. For instance, if we press Ctrl key and choose every control from the first row, the label, the text field, and the button, we can right click on them and choose Wrap in Horizontal Box. Automatically, a horizontal box container is added inside the anchor pane, and this horizontal box contains the label, the text field, and the button. Then we can define inside the layout section on the right the horizontal spacing for every component inside this horizontal box, so the fields are automatically separated with this spacing. We repeat the steps for the second row. We choose food category and combo box and grab them in another horizontal box with the same spacing, and then we do the same for the third row with food weight. We wrap them in a horizontal box with a spacing of 20 pixels. So this way we have every row of our form inside a horizontal box. Finally, we can choose by pressing Ctrl key every horizontal box from the bottom left section, and then right click on them and choose Wrap in Vertical Box. This way there is a vertical box inside the anchor pane, and inside this vertical box there is every horizontal box containing every row of our form. We can also set a vertical spacing for this vertical box to separate the controls properly. Now we can use this vertical box to fix the anchor points, but before this let's give an ID to every control that needs to be accessed from the controller. Starting from this text field, for instance, this text field is going to be called txt food name. The last text field will be called txt food weight, and the combo box will be called combo food category. The rest of components, the labels or the button, don't need to be accessed from the controller, so we don't need to give them an ID. Now let's go back to our vertical box, and from the layout section we can anchor the whole vertical box to left and right margins. So whenever we try to resize the window, these margins on the left and on the right will be preserved. But we can also add some more constraints to the labels and text fields inside this vertical box. For now, let's try to run the application and see how it behaves whenever we try to resize the window. This is the appearance of our application. If we increase the width of the window, we can see that labels and text fields don't increase their width to fit this new right margin or right space. And if we try to shrink the window, we can see that there is a point at which we can't read the contents of the labels. So we can fix both problems. We can set a minimum width for the labels in order to avoid losing their contents, and we can also set a maximum width for instance, for the text fields or the combo boxes to grow as many pixels as the window width lets them grow. Let's start with the labels. We need to choose every label, go to layout section and go to min width property. We must set all of them to use preferred size for the 3 labels. That's okay. So if we run again the application, we can see that if we shrink the window, the controls, the text fields and buttons also shrink, but the labels keep their preferred size. So we will always read the contents of this label for every possible window width. Now let's change the properties for the text fields and the combo box. We need to change the max width property of all of them to max value for both the text fields and the combo box. And we also need to change the horizontal grow property here to always, to let them grow every time they can if we increase the width of the window. That's it. So if we run again the application, we can see that if we increase the width of the form, the text fields also increase their width. The combo box has no effect with this horizontal grow property, but the text fields respond to this property and increase the width whenever we try to increase the window width. So we have set the layout of our main container, and now we are going to populate the table with some food items. But in order to do this, we are going to add a new package to our application. We are going to add a sub-package called healthymenu.data to store the data managed by our application. Inside this package, we are going to add a new class called food that will store every attribute that we need to store for a food item. In our case, we are going to define a name, a category, and a weight in grams. Once we have the 3 attributes, we can auto-generate the constructor to give a value to all of them, and then the getters and setters for every attribute, along with a toString method to have a string representation of every food item. In this case, in our case, the toString method will return the food name along with the category and the weight in grams, separated by semicolons. We will see later why we set this output format. Besides all of these methods, we are going to add an additional one. It will return a float value, and we are going to call it get weight in ounces. Inside this method, we are going to convert the weight in grams to ounces, applying a conversion constant. This is the final code. We multiply the weight in grams for this constant to convert grams to ounces. Now let's instantiate or initialize the controller. We are going to associate the controller to the main fxml file, and then we are going to populate the table and the combo box with some initial values. In order to set up the controller, we need to go to the fxml source file and go to the main container, look for an fx controller attribute, and if we can't find any, we need to add one of them, referring to the place where the controller is located. In this case, we need to refer to healthy menu views main controller. Now that we have the fxml file associated to the controller, we need to add every control to the controller referred by its own fx ID. Let's start with the table. For instance, we choose the yellow bulb on the left and create every field in the controller. Once we finish with the table, we can go on with the bottom form. Then we need to make every attribute private. And finally, we need to add the corresponding annotations, fxml annotations for each attribute by choosing the appropriate element from the red bulb on the left. At the end of this process, we need to have every control identified in the controller with its corresponding fxml annotation. Now we can implement initializable interface and then fill the code of initialize method. Inside this method, we are going to populate both the combo box of the bottom form and the table with some initial data in order to see how it shows in the main window. Regarding the combo box, we can add, for instance, these default values for categories: fruits and vegetables, meat and fish, milk derivatives, and other categories. We can also set the combo box to store string values so that we can get them easily later. And regarding the table view and the table columns, the table view will store food items, and we can add this class to the import section above. and every column is going to store a given attribute of this food item. For instance, call food name is going to store from a food item a string containing the food name. In the same way, food category is going to show a string containing the food category. Regarding food weight in grams, is going to show an integer with the weight of the food in grams. And finally, last column is going to show a float number with the weight converted to ounces. Now let's set up these columns in this initialize method and fill the table with some initial data. We can add this piece of code to set the properties of every column. Let's check what each instruction means. We refer to every column and call to set cell value factory method to determine the property that will be shown inside this cell. To do this, we use property value factory class that we can import to our code, and in the constructor of this class we specify the attribute name or the getter name that will be called to retrieve the value that will be shown in this column. For instance, in call food name we need to show the name of the food, so we create a property value factory referring to the name attribute. In fact, this name doesn't refer to the attribute, but it refers to the getter. So by adding here name, we are going to call the getName method and retrieve the name associated to the food. In the same way, if we choose a category for the second column, we are going to call getCategory method to retrieve the category, and so on. So this way we call getWeight method to get the weight in grams, and finally with this fourth name getWeight weight in ounces, we call this new method that we have already defined to convert from grams to ounces. So as you can see, every property value factory is associated to a getter from the original class, from food class, that retrieves the corresponding attribute to be shown in every column. Finally, we add some CSS style to the third and fourth columns to align the text to the right. As they are going to show weights, it is more appropriate to align them from the right than from the left. Now let's add contents to this table in order to see how they are shown. First of all, we need to add an additional attribute inside the class to store a list of food. In this case, instead of using a simple list, we are going to use an observable list that comes with JavaFX, and it lets automatically update the table with the list whenever this list is updated with new items, for instance. If we used a traditional list, we may need to manually update the table every time we add or remove anything from this list. But with an observable list, this update is automatic. For instance, we are going to add two food items to the food observable list through this method fxcollections.observableArrayList. We can define an array list and pass as many items as we need for initializing this list. In this case, we add some potatoes and some milkshake. And finally, we refer to table food attribute to set its items. We set as the table items the food observable list that we have previously filled. If we run the application now, we can see how this table is already filled with the corresponding values. But before this, we need to export our new package, data package, in the module info file in order to use food class from other parts of our application. Now we can try to run the application and see how every row is filled with the information that we have placed in the observable list. The potatoes and the milkshake with their corresponding weights in grams and in ounces. We could also improve the appearance of this table if we limit to 2 fraction digits the weight in ounces. In order to do this, we need to go to food class and make some changes in the get weight in ounces method. First of all, this method needs to return a string instead of a floating point value so that we can limit the number of fraction digits. Then we are going to use a decimal format Java class to specify how many fraction digits we need. And then we are going to return this expression converted to a string. This is what we get finally. We use a decimal format instance. We set the maximum fraction digits to 2, and then we return this expression converted to a string and formatted with 2 fraction digits. So in this case, in our controller, the column referring to weight in ounces is not going to refer to a floating point value anymore, since it's going to show a string value. This way, if we run the application, we can see the weight in ounces formatted with 2 fraction digits. Here we can see the final result. And now we are ready to add real food to this table instead of adding default values from the initialize method. We are going to read a list of food from a text file and place it in the table, and then we are going to activate the behavior of the button form to add new food items to the list and automatically store them in the text file. In order to read contents from a text file, we can use this method. It returns a list of food. We need to import list interface to our class definition, and inside this method we are going to use functional programming in order to easily read the contents from a text file called food.txt and automatically convert the information read from this file to food elements. Let's start by creating this food file. In the root of our project, we create a new file called food.txt and we populate it with some food initially. For instance, we can use these items, some potatoes, chicken, milkshake, salmon, each one corresponding to a different category with the corresponding weight in grams, and we need to read every line of this text file and convert it to a food item. As you can see, every element is separated by semicolons, so we need to split each line by the semicolon and assign each part to the corresponding attribute, the food name, the food category, and the weight in grams. That's what we do inside this method. We use files and paths class from Java Neo package to get to the text file and get all the lines, and then we use streams from functional programming to map or convert each line to a food object. To do this, we just split the line by the semicolon and assign each part to the corresponding attribute. The first part is the name, the second part is the category, and the third part that we need to convert to integer is the weight in grams. Finally, we collect the resulting list to a list of food that is automatically returned in this method. If there is any error reading the file, we return null as the list of food. Then we can use this method to automatically populate the food observable list. Instead of adding manually some food items to the list, we can just read the file and populate the observable list with the contents read from the file. Regarding file storage, we can use this new method. We use a print writer object that we need to import to open the same text file, food.txt, and then again using strings, using functional programming, we explore every food item contained in the list, in the food list, and print its information to the file using the toString method. The toString method, if you can remember, just outputs the food information separated by semicolons according to the format that we have previously specified in this text file. So if we use this method when we click on the add button, we automatically store the whole food list into the food.txt file with the appropriate format. Now it's time to add this event when clicking the add button. We go to Scene Builder, we choose the add button, we go to code section on the right and define the event or the method that will be called when we action this button. Let's call it add food. Then we go to fxml source file and add this new event to the controller. Finally, we need to specify the code of this event. What we're going to do is first of all check that every control of the form is properly filled. We don't allow any empty values in the form. If there is any empty value, we will show an alert message indicating that there can't be any empty values. If everything is okay, we're going to create or instantiate a new food object, add it to the food observable list, and then save the changes by calling this save method. This is the code that we are going to use. First of all, with this if clause, we check that every control has a valid value. We check that both text fields are not empty and the combo box also has some items selected. If something goes wrong, if something fails, we are going to show an alert message of type error saying that no field can be empty. If everything is okay, we add a new food item to the food observable list. We create this food item by getting the corresponding values from the form controls, the food name, the food category, and the food weight converted to integer. And finally, we save the file with the updated food list. Let's check how this works. When we run the application, the food.txt file is automatically loaded in the table with the 4 items that we have previously added, and then we can add more new food items to the table by using this button form. If we click on the add button without filling any of these controls, we should get this error message saying that no field can be empty. But if we fill the fields properly, for instance, let's add some tomatoes, which are fruit and vegetables with the corresponding weight. Then automatically this new food item is added to the food list. But even more, if we close the application and start it again, we can see that the table automatically incorporates the new food item that we have previously added, this tomatoes item. So now our application automatically stores and updates the food list properly. To finish with this project, let's add an additional scene to show a pie chart. To do this, we're going to add a new subpackage from Healthy Menu called healthymenu.views.chart. So inside views subpackage, there is a main subpackage containing the main stage, and now there is a chart subpackage that is going to store the fxml file and controller associated to the pie chart view. Inside this new package, we are going to add a new fxml file. Let's call it chart fxml, and a new class which will be the controller called chart controller, for instance. It's important to add this new package to our module info file in order to use it later. We can add it here next to previous view. And now we are going to define the layout of our new scene, our new chart scene. We open it with Scene Builder. There is an anchor pane as its default main container. We remove it. And we are going to add a vertical split pane as we did for the main stage. In this case, the top part will be bigger than the bottom part. In the top part of this split pane, we are going to add a pie chart. We go to Charts section, choose the pie chart and drag it on the top part of our split pane. We can right click on this pie chart and choose Fit to Parent. And in the bottom part, we're going to add a single button to go back to the main window, to the main scene. Let's call it Go Back. So this is the appearance of our new scene. We need to associate it to the corresponding controller so that we can refer to the pie chart from the controller. We go to the text of this fxml file. We assign an fx controller attribute to the main container, referring to healthymenu.views.chart controller, and then we can give an ID to the pie chart. Let's call it, for instance, pie chart. Then we add this control to the controller, we make it private, and then we add the corresponding fxml annotation. So we have the pie chart visible from this new controller. Now let's move to the main view and add a new button to show the chart view. We go to controls, we drag a button, for instance, in the second row. We can call it chart. We can resize it a little. And whenever we click on this button, we are going to hide this scene and show the pie chart scene. So we need to add some code to swap these two scenes. But when we go to this chart scene and click on the go back section, we need to do the opposite operation. We need to hide this scene and go back to the main scene. So we are going to use a static method that will be called from both buttons in order to swap between the main and the chart scenes. We are going to add a new package to our project. Let's call it healthymenu.utils. And inside this package that needs to be also added to module info, inside this package we are going to add a new class. Let's call it scene loader with a static method that will hide previous scene and show the new scene that we pass it as a parameter. This is our static method. It receives the new path pointing to an fxml file that needs to be shown and a stage to place the scene in, usually the main stage for every scene. We need to import stage class along with IO exception and some additional classes corresponding to JavaFX structure: parent class, fxml loader class, and scene class. So we load through fxml loader.load static method the new fxml path in a parent node, and then we build a scene with this fxml file. Finally, we assign this scene to the stage, to the main stage, and then we show the changes of this new stage. We are going to call this method from both the chart button in the main view and the go back button in the chart view. Regarding the main view, we click on the chart button and add an action event that is going to call a method called, for instance, go to chart view. Then we go to the fxml source file and add this new event to the controller. And finally, we need to add here the code to change to the chart view. We use scene loader class to call its static method. We need to import these classes to our source file. And as you can see, we load the scene referring to chart.fxml file, and the second parameter is the stage in which this scene is going to be located. With this piece of code, we get the stage from the event that has been fired. As this method may throw an IO exception, we can add this exception through a throws clause to this event. So whenever we click on the chart button, this code is going to be fired, and then we are going to move to chart fxml scene. On the opposite side, if we go to chart fxml and click on the go back button, we can add a new event. Let's call it go to main view. We go to the fxml source file, add this event to the chart controller, and then we are going to use a similar code to go back to the main fxml view. Again, we need to import the corresponding classes: scene loader, stage, and node. And we also need to throw or declare to be thrown IO exception. Then, as you can see, we are going to load or move to main fxml scene. And we also use this piece of code to get the main stage from the action that has been fired. So let's check how this works. But before doing this, let's pay attention to a bug that I've added to these events. Regarding this path, there is no scenes folder in my project since I've called it views. So it's important to refer to the appropriate package, healthy menu .views.chart, and in the same way in the chart controller we need to refer to views subpackage. Now if we run the application and click on the chart button, we can see this new chart scene, and if we click on the go back button, we move to the main scene again. So this scene swap is working perfectly, but finally we need to fill the pie chart here to show the summarized contents of the table. In order to do this, we need to implement IntelliJ interface as usual, and then add the code for the initialize method. Inside this method, we need to, first of all, we need to refer to the food list that is located inside the main controller. So we are going to add here a public method that is going to return the list of food, the current list of food. Then from the chart controller class, we need to access this controller and call the getFood method to get the food list. To do this, we need this piece of code. We use again fxml loader to load the main application. You need to import this class. Then we get the root element of this fxml file, and from this we can get the controller as well. Through this controller, we can get the food list of the table. Next, we have this piece of code to fill the pie chart. We clear previously that data, if any, and then we are going to build a map with strings as keys and integer as values. We are going to map every category with the sum of the weights associated to the food belonging to this category. So every food belonging to, for instance, fruits and vegetables is going to sum their weights in the fruits and vegetables category. Finally, in this result map, we are going to have each category with the corresponding sum of weights. And then we explore the map and add a new piece to the pie chart corresponding to every category of the map. As we can see in this for each section, we explore every pair of category and sum and add a new element to the pie chart associated to this category and sum of weights. We can see how it works if we run the application. This is our main window. If we go to chart button, we can see the pie chart with the corresponding categories: meat and fish, fruits and vegetables, milk derivatives, and the sum of weights associated to each category. So if, for instance, if we add another element to the table, for instance, some bread, which is associated to other categories, and we run the chart or we show the chart again, we can see how the chart is automatically updated with the new weights and the new categories in this case. To finish with this example, we could also show the chart in a separate model window instead of using the same window than the main stage, the main scene. Let's change the code of this chart event in order to show the chart in a separate window. We go to the controller class and let's comment these lines. And instead of them, we are going to add here the lines to open this chart scene in a separate modal window. This is the code that we need to open a new window. We refer to the chart fxml. We define a new stage called secondary stage, and we set it as a modal stage from the main stage. What do we mean with this? Well, if we open a modal stage from a main stage, we can't go back to the main stage until we close the modal stage. Okay, so let's see how it works in this case. This is our main stage, and if we click on the chart button, another new window, new stage is now shown. And if we try to go back to main window, we can't, since this is a modal stage. We need to close this stage in order to go back to the main window. In this new situation, the go back button makes no sense, because if we click on it, then the main window will be loaded in this secondary stage as well. So if we decide to implement the application with a modal window, then the go back button makes no sense. We just close this secondary or modal window, and then we can go back to the main one. So there are two ways of implementing this additional scene: through a new scene in the same stage, or through a modal window apart from the main stage. In this case, as soon as we close this new window, we can go back to the main stage. So we have built a more complex and complete application with several packages, several scenes and fxml files, several events, using tables, updating tables from an internal list, in this case our food list. And this is the correct way of implementing more complex applications in JavaFX.